Assalamu alaikum. So in the last lecture we were talking about fundamentals of signals. This particular lecture is about introducing images. Now, bioimaging is a huge domain which includes all of these topics. Now, we will be sharing with you an assignment where we would be discussing the application of one of these, or some of these you could say. Specifically, in fact, it will be the MRI that we would be discussing. Now, within bioimaging, you have tomography, radioscopy, ultrasound, MRI, PET scan, CT scan. Now, some of these are in fact, not all of these, some of these are included in this course. As an example, now fundamentally any particular image that you see is represented in either grayscale or what you refer to as color, gray level images or color images. Now in a gray level image, the maximum value, every coordinate is represented by a value where the maximum value represents the brightest point and 0 represents darkness. Any value in between is just this shade of that particular gray. Now popular gray levels are between 0255, 0511, 023 and so on. Here is an example of a gray level image where the gray scale is between 0 and 255. Now if we reduce the gray scale of this image to 0 to 63, you do see a difference. The resolution has reduced. Now if we reduce it further to a binary level, 0-1 image, this is what you see, because all you have is either a particular coordinate is dark or it's bright. There is no in between. Therefore you lose a lot of the resolution. At the same time, if you talk about color images, each coordinate or each point or each pixel is represented by an RGB value. So what you have is an entire matrix of R, G and B where the value or the relative value is responsible for all the combinations of colors that you see. So these three numbers collectively are responsible for any given coordinate, are collectively responsible for all the colors out there. An important principle amongst images is the image histogram, and you will see an application of that in probably chapter 3 and chapter 4. Now, the image histogram tells you of how many, what is the probability mass function of your particular image, and it has good uses, which we will discuss later in chapter 3 and chapter 4. For now, an image histogram is a probability mass function of your gray level image. Here you have 9 total points, therefore N stands for 9 because there are 9 points, so there are 9 pixels or whatever, there are 9 boxes in this case. And this represents the brightest point, so there's only one of those, so the probability is 1/9. This on the other, or the brightest level being 2, the darkest or level 0, there are 3 values, so 3/9, that's this guy here, and obviously this guy which is in the middle is 1/9. Again, the histogram has a lot of uses, and we will see that in the later chapters. In this chapter, all that we have seen is there are images. These images either are represented in color, and therefore each coordinate or each pixel has an RGB value. R stands for red, G stands for green, and B stands for blue. The level of red, varying the level of red, green, and blue, gives you all the images, all the colors that you see. At the other side, we also have gray level images, where 0 represents the darkest or black, maximum value is white, and everything in between is gray. Therefore, the word gray level image. And the third concept we discussed was the image histogram. Now, this completes these 3 lectures, complete chapter number 1. Next, we will discuss chapter number 2, or what is referred to as the Fourier transform. Now, the Fourier transform as a precursor is one of the most widely used tools in physics, engineering, and computer science, because it very nicely transforms a time domain signal into a frequency domain signal, and vice versa. So, inshallah ta'ala, see you next time. Thank you very much, and have a wonderful day. Assalamu alaikum.